Today's video will be doing the reaction mechanism for the Michael reaction in carbonyl condensation reactions. So a possible way the exam might ask this problem is, given this compound, what reactants do you need, and please draw the mechanism for it. So the fact that I'm seeing two carbonyls make me wonder where are the alpha and where is the beta. And the fact that we have a large group attached to the beta makes me wonder that possibly, well actually it could be this group as well, possibly that this might have started from an alpha beta unsaturated carbonyl, because when you have a conjugated carbonyl, that is when the beta carbon will attack or will join with the alpha carbon. Otherwise, in reactions such as aldol reactions, the alpha carbon joins the carbonyl in aldol reactions, and in alpha beta unsaturated compounds, the alpha carbon joins the beta carbon. Okay, so now that we know this came from an alpha beta unsaturated carbonyl, let's do the reaction of this Michael addition. So this is what we started with. This could be one of our reagents, and another one of our reagents could have been this, with a conjugated bond right here. Okay, so this is where it joined. So where the alpha and beta was, you just put an alkene in between it, then you split this bond. Okay. And then this is alpha carbon. Okay, so the reaction mechanism here is pretty much identical to the aldol reaction. You always start with deprotonation and forming an enolate. Which can also be written as this, which is slightly better. This is our nucleophile, which will attack the Michael acceptor, aka the beta carbon. This passes on, this goes on to the oxygen, and we have solid arrows here. And now, make sure to draw the alkene, don't forget about it. Now I attach this alpha carbon beside this beta carbon, and the ketone's right beside it. So then, of course, we, in the products, no longer want an unsaturated system, so this alkene's gotta go. So some textbooks will draw this step as such, where we draw the enolate in another way, which looks prettier, like this. So two different ways of drawing it. So then they get protonated. Or you could draw it like this. Depends on what your textbook wants, but both should be fine. So that gets protonated, and you will basically just have your product here, but now it is protonated without this negative charge. So this is the Michael addition of condensation. Major takeaways is that the beta carbon joins the alpha carbon. And if you're given the product and asked to figure out the reactants, if you see a lot of big major stuff attached to the beta carbon, then you know it was a Michael reaction and not an aldol reaction. And make sure to keep track of all your alkenes. For example, don't forget to draw the alkene here. In your products, there should no longer be any more alkenes.